Our next speaker has flown all the way from Japan to specially present to us this afternoon. I would like to introduce Shinya Kogawa, Director with Nikken Sekkei. Shinya Kogawa is on the board of directors at Nikken Sekkei Construction Management, one of the most prolific construction management firms in Japan. Shinya joined Nikken Sekkei as an architect in 1990 and has over 27 years of experience in the design and management of offices, data centres, hospitals, community centres and various other building forms. In 2006, Shinya became chief architect and was involved in projects with a focus on renovation. He currently heads over 90 members of the Tokyo and Osaka studios, providing not only construction management services, but life cycle management and design services for renovation projects. Please join me in welcoming Shinya to the lectern.
Good afternoon, everyone. Thank you for coming to this conference today. I hope that you have had a good time so far. Firstly, I have to apologize to all of you. I'm not good at speaking English. But don't worry, I prepared all the script of presentation. How brilliant are Japanese people. My name is Shinya Kogawa. I'm one of the directors of Nikken Sekkei Construction Management. I used to be an architect, especially in renovation domain. So I'm making use of my past experiences in CM service too. Nikken Sekkei is an architects firm established in 1900. We are a very old company which has created many famous buildings. For example, the Tokyo Sky Tree, which is the tallest telecommunication and observatory tower in Japan. It's 634 meters high. This picture is the Kyoto National Guest House, which many state members have stayed in. My firm, NCM, spun off in 2005 as a construction management service firm. The current number of employees is around 230, and the total number of members in the group is 2,600. NCM provides various management and consulting services not only in Japan, but also in many foreign countries. This slide shows our different experiences all over the world. Now, I'd like to talk about today's theme of asset enhancement. From 1987 to 1992, it was a bubble era in Japan. But in 1992, the bubble economy suddenly burst. This graph shows the shift to prefer refurbishment in Japan. This blue section represents building investment, and the green shows renovation investment. As you can see, about the bubble burst, investment for new buildings had declined continuously. On the contrary, renovation has increased to over 30% of the total construction investment volume. After such a change of social background, there are more aspects we need to take care of now. For example, business continuity, environment, legal compliance, IT of such facilities, and so on. We must be concerned about not only providing periodical adequate maintenance, but also improving facilities in a comprehensive manner. I think it's very important to have a viewpoint about sense of life cycle management and to develop a strategy before starting to plan or design. We, the Nikkei Group, have begun to expand our business domain. This figure shows about group service capabilities for renovating buildings. Architects firms provide only the service area highlighted in green. But various social needs are based on stock society, which demand diverse services. For example, our clients want investment strategies in the pre-design phase and to have long-term maintenance investment plans for post-completion. Next, I will introduce several of our unique projects concerned with asset enhancement. Today, I will talk about our 4 projects. All of them are renovation projects, but they have different purposes. The first project was a seismic reinforcement work of an old hard disk drive plant facility. This facility was built in 1967 as IBM's factory. After that, a Japanese electric company obtained this facility. In 2011, a huge earthquake struck East Japan and made them decide to strengthen this building. According to the seismic diagnosis, it needed to be strengthened by adding many horizontal braces under its roof. Before installing such braces, the ceiling, pipes, electric cables, air conditioning ducts, and so on need to be removed. And after installing the braces, these parts would have to reinstall it. It would take a long time to finish these works, and the operations of this factory must be stopped for an additional year beyond the standard. It's a big opportunity loss and obstructs business activity. So to prevent this problem, we proposed an innovative method of construction. This figure shows the factory's building section around the roof. This factory's roof consists of lightweight concrete panel. NCM proposed a unique proposal that was to cut off the roof panels around the top of existing columns and extend columns. The tops of the columns were then connected by horizontal braces above the roof. Using this method, the factory could complete the seismic reinforcement without suspending operation. To realize our proposal, there were several issues to be solved. One of the difficult issues was how to prevent rainwater leakage from the roof during construction. So to solve this issue, we planned to make a temporary roof around the columns where there could potentially be a leakage. Another issue was how to prevent heat breach. If the insulation was not enough, a lot of trouble could occur, such as the condensation dropping around the columns. We planned to insulate around the base of the added columns. In addition, the added columns base was painted by insulating paint. Finally, we are able to shorten the construction time to 14 months, and construction cost was reduced by 1/3. Above all, we could keep the factory operating during the seismic reinforcement work. We couldn't know benefits of quantity in business continuity, but it should be more than the reduction of construction cost. This is a photo of the completed roof. And this is an aerial photo. As you can see, These steel reinforcement parts were placed above the roof like a mesh. It was a never seen before sight and the world's first challenge. The second case study I'd like to discuss is the resurgence of a bankrupt mega resort. This resort area was developed in 1994. There are many facilities in this area: 3 hotels, 2 golf courses, international convention halls, a huge indoor pool, a tennis club, and condominiums. The investment volume at that time was about 2 billion Australian dollars. Several years after, the company operating this resort area went bankrupt. In 2012, an entertainment company in Japan bought it. The company asked us to investigate all of the facilities in this area and estimate the long-term maintenance cost. Our diagnosis of these facilities showed the performance of investment concerning maintenance cost. Our clients decided on how to maintain these facilities. The big hotel and golf courses, condos, and convention halls were more profitable than other facilities. On the other hand, non-profitable facilities, such as a huge pool and 2 old hotels, didn't have any potential, even if they continued to be operated and maintained. So they decided to demolish these buildings based on the company's management policy of selection and concentration. The series of renovation and demolition projects began. This chart indicates the project master schedule. As you can see, several projects made progress at the same time. The renovation work of the 45-story hotel was our major project. The number of guest rooms was more than 700. We participated in the project as a construction manager. We supported our client to choose the designer to manage bidding, review design drawings, shop drawings, and other documents about construction works. And finally, we inspected the completed work. This hotel interior finishes are fully renovated. This is a renovated standard room. And this is luxury guest room. And this is reception area and bar lounge, elevator lobby, and the other public areas. The guest room's renovation was conducted by a variety of designs. In the high-grade guest rooms, outside view bathrooms were added. And several guest rooms were converted to a guest lounge like these photos. The demolition work of the huge indoor pool facility is ongoing. This facility is 300 meters long, 100 meters wide, and 50 meters high. So it's very difficult to make a demolition work plan. We asked several contractors for a quote for the demolition cost and a plan for how they would demolish it. One contractor's proposal was to use the heaviest tear-down machinery, of which there are only 3 fleets in Japan. Using this tall machine could reduce complicated scaffolding and cut costs. This demolition work is in progress up to this moment, and it will be completed by this August. Now, I'll move on to the story of the renovation of an office building. It was in 1966. At the end of the 1990s, our client asked us to study this building that was decrepit and weak against earthquakes. We compared the benefits of replacement against renovation with several factors in mind, such as cost, schedule, environmental friendliness, and others. If the whole building was replaced, it would take 3 years, including the demolition period. On the other hand, we tried to renovate it totally, replacing exterior walls and windows, seismic reinforcement, interior finishing, and all equipment and appliances. It could be completed within 9 months. Regarding the comparison of construction costs, the renovation cost would be around half of total replacement. When the building was originally built, there were no regulations about floor area ratio in Tokyo. There was a regulation for building height only. The building's floor area ratio was over 1,000% when acquired, in spite of the current floor area ratio regulation, which was 800%. So if that building was replaced, the rentable area must be decreased. It's no wonder that opportunity loss during renovation construction period would be less than full replacement. So we proposed a full renovation to make it like a new construction, presenting a difference in total cash flow as shown in this figure. The comparison of profitability showed the positive effect of a shorter construction duration, a reasonable construction cost, and the merit of big leasable areas. Exterior walls were replaced to lightweight aluminum and glass curtain walls. This weight saving has contributed significantly to improve its seismic capacity. Facades were totally changed to a contemporary design. It consisted of horizontal louvers and vertical fins, preventing direct gain from sunlight. It's also an eco-friendly exterior wall system. Regarding the typical floor, there was no raised floor for wiring, and ceiling height was only 2 meters before renovation. After being renovated, we could increase the ceiling height to 2.6 meters and install a 7-centimeter high raised floor, which allowed us to control a way to manage ducting and wiring inside the ceiling. This is a renovated office space. The ceiling was bevel-shaped for ducting inside the ceiling. This photo is the entrance lobby before and after. This is the elevator lobby of a typical floor before and after. All fixtures and equipment were replaced similar to those of brand new buildings, and we could make it earthquake-proof. In addition, rent income of the renovated building went up approximately 1.5 times compared with the previous rent income before the renovation work. So the investment for the renovation work was recovered in 3 years. And finally, I'll talk about a renovation of a symbol of a city. Yokohama City is 40 kilometers west of the Tokyo and has a population of 4 million like Melbourne. The Yokohama Marine Tower was built in 1961 in commemoration of the 100th anniversary of the opening of Yokohama Port. This tower used to be recorded in the Guinness Book of Records as the tallest lighthouse in the world. It had 2 levels of an observatory. It was owned by a private company, but the number of tourists had decreased year by year. And finally, the company couldn't maintain the facility. The Yokohama City government decided to acquire the tower and plan a full renovation for its 150th anniversary. The tower wasn't free quake-proof and was dilapidated. We investigated in detail and proposed a renovation plan. The observatory, exterior walls, and windows were totally replaced. The body of the tower was strengthened, adding new steel parts and painted by long-life paint. The base of floors of the tower were wrapped with a new structure and glass curtain wall. This is a plan of a lower base. The purple-colored area was expanded like a ring. The issue with the project was not only how to renovate the tower, but also how to increase visitors and continue performance of business. Before renovation, the tower was a simple resource for tourism, like an observatory and souvenir shop. Yokohama City government implemented a proposal to choose a private company and leased this facility to them to operate for more than 10 years after this renovation. We also supported the city government to manage this selection of the tower operator. The company which was selected converted the facility to a chapel, banquet hall, and restaurants. After completion of this project, the number of tourists visiting this tower has doubled compared to before. It has been successful and profitable. It has been 8 years since the completion of the renovation. We are forever concerned about the next decade and the future of one of the symbols of Yokohama City. With that, I come to the end of my presentation. I think it's important that the designer, project manager, construction manager, and consultant must consider not only design and engineering, but also economical potential and business sustainability from a long-term perspective. In closing, I'd like to thank you all for listening attentively. It would be great if you could ask simple questions using easy words. Thank you again.